Whoa. We are a, that is really loud. There we go. We are a software company that does provide process automation, but this is not a sales pitch, right? What I want to try to do today is give you a different way to approach solving some technical problems within your software. I've been in software development for 20 plus years, I think 22 years now in various roles. I'm an Oreo enthusiast. They are the best cookie, and if you disagree with me, you can leave now. And I love playing chess. If anybody got into the chess boom in the last couple of years and you want to challenge me to a game, you can find me on Lee Chess and Chess.com. I would love to play them. And I wear a balloon on my head. Why? Because it's fun, and it helps me stand out, and it makes me easy to find in the crowd if you want to ask me a question later. So I titled this talk, Orchestrate the Chaos, Process Automation in Modern Software Architecture. I'm not going to get into a big debate about what is modern software architecture. If you go Google it, there's a lot of different options that are out there. Microservices, distributed systems, blah, blah, like it's just this giant checklist that you can go down. But ultimately the problem that we're trying to solve is a whole bunch of buzzwords that I threw into this little word art bubble, right? We want something that's observable and fault tolerant. We want it to be understandable, interoperable, performant. We want it to be reliable and available, etc. These are the core problems that we're trying to solve when we talk about these different software architecture patterns. And just to illustrate one, I'm going to use microservices. It's a little dated at this point, but I think it's one that everybody sort of understands, and I think it's very easy to visualize, right? You used to have this one application running on one server, now you have a bunch of tiny little applications running on various different platforms. And this is one way to achieve that, right? We're separating out our services, each one's a little bit more durable. Each one, we can scale it up, we can scale it down as we need it. It's very easy to work with. But when we're talking about these modern software architectures, they're great at optimizing resource usage, right? Like that is ultimately their primary goal. We want to make sure that we're using the resources we've deployed them onto as efficiently as possible and as cost effective as possible. We want to be able to scale up the services that need it, scale down the services that don't need it. That's really what we're trying to solve, right? Cost efficiency. That's what reliability is going to get us. That's what availability is going to get us. That's what easier onboarding for our engineering team is going to get us. It's cost efficiency. So when we're talking about these architectures, a lot of times we're talking about hardware and networking, right? We're talking about the cloud, and we're going to deploy it to this durable function in Azure, or we're going to have a Lambda function, or whatever it might be. The problem is that's not how the application actually functions, right? Inside of your application, you have business logic that follows through each of those services. When somebody clicks a button, when there's an operation that occurs within your software, there's a series of things that happen inside of it. And so now, we've been talking about architectures, servers, resources. Now you want to go diagram that and try to explain how it works, and it looks like you threw spaghetti at the wall, right? I think almost everybody's tried to do this in some capacity. It's really annoying. There is a great YouTube video, if you haven't looked it up. It's just like search like microservices comedy short. It's not safe for work, so I didn't link it in the slides, but it's absolutely worth watching later. And of course, like when we look at this, it's disgusting, it's terrible, it's not easy to make sense of. This works as an architecture diagram. This does not work as like a business workflow diagram, right? And genuinely, this is the face that my dad made when I tried to explain what I do for a living. Inside of these modern software architectures, there's hard problems to solve. They're not impossible to solve. We have solutions for them, but they're not particularly elegant, especially when you compare how you might have done it within a monolith before. For instance, documentation, right? Trying to document what service depends on what service and where and when it gets called and which one subscribes to which queue or Kafka topic. It can get really confusing, and it makes the documentation harder to maintain. Timers. if you have alerts, notifications, if you have something that's stuck in the database and should have been processed yesterday, right? Now you need to have some sort of system that's going through and pulling out all of those and doing whatever operation needs to happen to clear that queue. Again, not impossible to solve, but maybe not as elegant as it used to be when everything was just running in the same application memory space. Interrupting messages, same sort of thing, right? Transactions and rollbacks, same sort of thing. If you have a monolithic application all deployed on a single server and you have one transaction that you need to roll back 7 steps of because you had a failure, it's a lot easier to do that when everything's sitting in memory versus when everything's distributed on its own independent system. And now each one needs to remember what it needs to roll back. Your system has to remember which one it needs to call to roll it back. And again, there's ways to do it. It's not impossible. It's just a slightly harder problem to solve. And then, of course, changes to business logic, right? Depending on the scope of that change, you might be touching multiple services now, engaging multiple teams, whereas before you just had a single code base, and it might have been a little bit easier. So my proposition today is forget services, forget the infrastructure, forget that sort of traditional way that we tend to think about software engineering. And I want everybody to think about it in terms of processes. Processes is defined by the dictionary as a collection of related structured activities or tasks performed by people or equipment. It's fintech, so this is a really basic, please do not judge this for people that work with loans. But I think a loan application is a very simple process to understand. Regardless of the financial institution that you're going through, there is a set number of steps that that loan is going to go through. You're going to receive the application. There's some sort of background check that has to happen, a credit report. Are we going to, automatically decline them or not? Has to go all the way through to signing the paperwork, dispersing the funds, collecting payments, et cetera, et cetera. And it doesn't really matter what type of loan that is. Is it an auto loan, a home loan? The same kind of basic workflow happens end to end. So this is what I mean when I say a process. We're not thinking about it in terms of services. We're not thinking, oh, we need to have a payment collection service that we're going to deploy to AWS. No, no, no. Forget that. Think about the actual business steps that it goes through one by one. So to illustrate what I mean by this, I'm going to talk through a real-world example. This is a fintech conference. This is not a fintech example, so bear with me here. But this is a genuine example from my consulting days, back when I kind of wish I was thinking about solving problems in this particular way. So the customer I was working with, they were doing trucking permits for municipalities. And we're talking like the oversized, overweight trucks that you see driving down the highway, right? So for every single one of those trucks, they have to fill out an application, they have to get a permit, they have to pay some sort of fee to be able to cross through that municipality. And there's different levels to that. The states have their own rules, counties have their own rules, cities have their own rules. So there's this kind of tiered system that the trucking companies have to go through to apply for these permits and get them. And we were trying to automate that. We were trying to make it simpler for the trucking companies. But the basic process, regardless of where they're driving or what their load is, was the same. They fill out an application. We have to match that application to some sort of permit that has some sort of fee that they have to pay. Then the trucking company has to pay for that permit, and then we issue them the final permit, which gives them the legal permission to drive down the road. So kind of thinking about it in that quote-unquote old way, right? We might have some sort of like user form, micro front-end service that delivers the application form for them to fill out. They submit it. It goes to some sort of permit matching service that's out there. We can scale that service up and down depending on the number of permits we're receiving at that particular hour. Then they've got to pay for it, so we have some sort of payments back end for that. And then we issue the permit. There's got to be some sort of service that takes it and emails a notification or whatever needs to happen. But I'm proposing don't think about it this way. Think about it like you're in Visio, right? Step 1, we're going to submit the form. Step 2, we're going to match it. Step 3, step 4. Linear, straightforward. This is very easy to visualize, very easy to understand. But then, of course, you're in the middle of developing this, your product manager comes in and says, no, we have a new requirement. The new requirement is that permit, at the end of the day, it's got to be a PDF, and we need to email those notifications out to everybody involved. Okay, cool. So again, thinking in the old way, well, maybe we're going to have some sort of PDF service, and we're going to have some sort of email notification service out there. Okay. Again, I'm proposing that we think about it in a slightly different way, and instead we're going to have 3 additional tasks that happen at the end of this workflow. Doesn't matter how they're deployed, doesn't matter what code they're written in, we just have 3 different services that now happen at the end. And if you've ever played around with Visio, right, tried to make some sort of workflow diagram, especially like way back in school days doing like the science fair or something, this looks very familiar, right? So we have step 1, 2, 3, 4, and then we have 3 steps that are going to happen at the same time to finish out our process here. And so, okay, you start programming the PDF service, you start figuring out how you're going to do email notifications, and they come in with a new requirement, and hey, we have to change something again. The user tried to fill in the form, it didn't match a permit. So now that process got stuck on that second step where it didn't match a permit, there's no fee to be collected, there's no payment to be made. Okay, well that's pretty easy. So now we need some sort of flag that comes out of that step that says, did it match? Did it not match? If it didn't match, now we have this additional task for some sort of manual validation that's going to occur. We're going to go in, we're going to apply a fee to it manually within the application, and then we're going to be able to collect the payment and move on with the rest of the steps. Very straightforward, very easy to visualize what's happening within the system still. Of course, we have a new requirement from the product owner. And if they don't pay in a certain number of days, the permit needs to be canceled. This is a true story. When we launched this application first, we didn't have this feature, and we found that there were a couple trucking companies that realized they could apply for the permit and let it sit on the payment screen. And if they got pulled over on the highway, they could real quick bust out their phone, make the payment, get the PDF delivered to their email before the cop showed up at the front door, and then they could show the cop that, oh no, we have this permit. But if they didn't get pulled over, they didn't pay, which is still illegal. So that's a true story. So we implemented this. And so now, for all the engineers in the room, if you were trying to think about solving this problem, right, and you have this payment stage, and now you need to cancel this payment within a certain number of days, and it needs to be configurable based on the type of permit that was matched before, how might you go about solving that? Right, there's lots of different ways to do it. I come from the .NET world. The way we implemented this was just using Hangfire in the background. Just a simple, basically a cron job that ran on an hourly basis and queried the data and checked the date values and did what it needed to do. But in order to do that, we had to deploy all of these changes to the code base. Again, solvable, not impossible, not even particularly hard necessarily, but it's not always a very elegant solution, right? Sometimes putting in this type of timer, this type of interrupt process can feel a little bit hacky sometimes. So this is where I want to introduce you to one of those acronyms that I threw out at the beginning, BPMN. So it stands for Business Process Model and Notation. It's a maintained spec. This is not vendor lock-in. This is not something specific to Camunda or any other company. This is an open spec maintained by the Object Management Group. I'm sure most people have heard of UML or are familiar with UML. It's the same group that maintains the UML spec. So this is an open international standard. It's visual, right? It's easy to understand these complex processes. There's no more spaghetti. There's no more weird diagrams between all of these servers, nothing like that. And the biggest benefit, which we're going to talk about how all this comes together in a minute, is you're able to bridge that communication, right? You can simplify discussions with stakeholders, especially the non-technical team members. You can unify the design and implementation stages. It's much easier to onboard new developers. So I'll get to how that all comes together in a moment. This is one of our kind of go-to BPMN diagrams. This is ordering pizza. This is not an actual system that you would implement in code, but you can see that somebody's hungry for pizza, so we have some sort of start event that kicks off this process. That's what the circle at the beginning means. They're gonna select a pizza, they're gonna order the pizza, and then there's this little diamond gateway event that happens. And if there's 60 minutes go by and they still don't have the pizza, they're probably gonna call the pizzeria and demand a refund, right? Like, you know, you get it in 10 minutes or it's free sort of a thing. And then down below, we have basically a sub-process. So when they order the pizza, another process is kicked off, so to speak, within the pizzeria where they've received the order, they have to make the pizza, they have to deliver the pizza. If they get that complaint from the customer, they have to calm the customer down, reassure them that the pizza's coming. This is what BPMN looks like. And I think even though maybe one guy raised his hand a little bit for BPMN, nobody else in this room has experience with BPMN. I think if you look at this diagram, you can understand what's happening most of the way, right? With no other experience, you can look at this, you know what's going on. It helps that you've ordered a pizza before. I'm sure everybody in this room, I know the gentleman handing out pizza certificates earlier has ordered a pizza before. But I'm sure everybody's ordered a pizza, so that helps too. But again, looking at these symbols, it sort of makes sense. It's very understandable. So if we were to come back to my previous example and we were to BPMNify it, so to speak, it would look like this, which looks very, very similar to what we saw just a couple slides before. The differences are we now have a start event, the circle at the beginning. We have an explicit end event, the circle at the end. We now have some additional diamond shapes. That's semantic BPMN. You want to kind of rejoin everything within a gateway. I'm not here to teach you BPMN though, so that's all I'm going to say on that. And then the other thing you might notice is there's a couple icons on the rectangles, and we'll get to those in a minute. But first, I want to go back to that new requirement that the product owner came in with mid-sprint and said, you have to do this right now. This is the new critical thing. Of course, they're disrupting the development workflow. Sorry to any product owners and product managers that might be in the room. I'm making jokes at your expense. So if they don't pay in a certain number of days, the permit needs to be canceled, right? Okay, so we're gonna go back to our diagram. BPMN has a very convenient way to model that, to visualize how that might look within a workflow. And that's this little timer event in the middle. So we have a timer event, we're gonna give it some sort of value, 7 days, and when that timer event fires, we're gonna move to that step below it where we're gonna cancel the permit application, and then we have another end event, so we're gonna end the process entirely. Again, without knowing BPMN, without knowing anything about trucking permits beyond what I've already shared, I think everybody can kind of look at this diagram and understand the logical flow of what's supposed to happen within the application, right? You may not know the exact values, but you understand the basics. And at this point, right, it's a picture. Everybody's been in Visio. Everybody's made a diagram like this. Everybody's stood at the whiteboard, right, and drawn arrows between everything. This is an actual quote from a workshop I gave once. Some dude in the back literally said, "That's great, dude, but it's just a picture." It's not just a picture. That's the power of BPMN. So I'm gonna let this run for a minute just because I like the colors and the dots and I'm a simple person who enjoys that. But this is the idea behind BPMN. Not only do you have a standard language, the BPMN spec, for defining how that workflow should work and function, not only do you have that, it's executable. Sorry, there were some pictures. Did everybody get the picture of the pretty moving colors? All right. That's where BPMN engines come in. So not only does the BPMN spec give you a very standard way to discuss and model and diagram how these logic flows should happen within your application, it also gives you a way to execute them. There's a lot to choose from. This particular screenshot is from the MIWG, which is the Model Interchange Working Group. And so the idea is, I don't remember if it's twice a year or once a year, But a whole bunch of BPMN vendors get together, and they all have a specific model, like a process that they need to put together. They model it within their software, export it, and then the test is, can all of the other BPMN vendors import that process? Like how much are you following the standard? The 2024 version happened just like 3 weeks ago or something, so there's some new results. This is a little bit old at this point. My company, not to boast, is at the top, Camunda. There are lots of other ones that are out there too, Signavio, AppFlow, SAP has their own implementation. There's IBM has an implementation. Activity is still out there. There's a lot of different vendors that are out there. So this to me is one of the key selling points of BPMN, right? You're not locked into a specific vendor of any kind. You have this BPMN workflow. You might need to make some changes to how your code kind of integrates with that workflow, which I'm going to talk about in a minute. But the flow itself is still executed by the engine, and you can switch software if you want. If you were with Camunda and you're like, they're too expensive now, or I don't like that Nathan guy who wears a balloon on his head, freaks me out a little bit, I want to go with a different company, you can export that diagram, import it into another BPMN engine, and you're off to the races, right? You're not rewriting a whole bunch of code. So let's come back to that diagram real quick. This slide is missing some circles for some reason. All of the little symbols were supposed to be circled in the top left. So what BPMN gives you is, again, that standard language to discuss things. You have the start and end events, which are circles. You have, we call them gateways, which are the diamonds. The gateways with the X's are an OR gateway, basically, right? You're either going to go one path or another path, depending on some value that you set. The one with the plus sign is a parallel path. So when it hits there, it's going to fork. All three of those are going to happen at the same time until all three are complete. They're going to rejoin and then move on to the end event. We have the timer event that's attached to one of the rectangles. You can have interrupting events that will actually cancel the process, move the state of that process from wherever it's at down into a different path. Or you can have non-interrupting events, which we'll talk about in a minute. And then you have the rectangles. Rectangles are this kind of generic task, is what they're called in BPMN. But there's different types of tasks. There's the kind with the gear. That's a service task. So this is some sort of process that's going to be triggered in some sort of external system. Maybe it's your system, maybe it's a partner system, maybe it's an API that you're calling. But it's some sort of little bit of code that's going to run somewhere. And then there's the human one, which is kind of in the bottom left there, the manual task. That means that some person needs to have some sort of interaction with that task. So when the workflow, when the engine gets to that task, it's going to pause until that step is completed. And if we kind of try to diagram this back out to our old way of thinking, that first step, match the permit fee, well, that's going to call some sort of permit matching service. The collect payment step, we've got our payments backend for that. For the email notifications, we have two different tasks that are doing email notifications, but they're both going to consume the same service on the back end. And how this actually functions is going to vary a little bit between your different BPMN vendors. Generally speaking, you're going to have some sort of job worker. So you've got a little bit of boilerplate code that connects the code that you're writing to the engine. And when the engine gets to, say, the email task, it's going to say, hey, I've got a job queue, we've got an email task. That job worker is listening for that email task, sort of in a pub-sub relationship, and that job worker is going to run. It's going to receive a little bit of data from the process, it's going to do whatever it needs to do, send a complete response back to the process, and it's going to move on to the next step over and over again. There are other ways to do that. Camunda specifically, we support something called connectors, which is meant to be sort of a low or no code reusable job worker that you just kind of drop in. So you write it once, you drop it in, and then you don't have to write it again. You just fill in some configuration parameters. For instance, a REST API call. You plug in like your OAuth, client ID, and secret, a URL, whatever the payload needs to be. The connector automatically makes that webhook call, returns the response, process moves on. But the point I'm trying to make here is that This diagram in its executable fashion has these small little hooks that call back into your application or have the ability to call into another application. And that's how you keep the data moving forward, right? And the idea here is that we're taking the state of the process out of your application, and now it's going to be managed by the workflow engine. Your application is still going to manage the data. It's still going to keep track of all of that, do all of the data manipulations. It's going to understand, customer first name, credit card numbers, whatever. That's all still within your application. But where that particular loan applicant is within that process, that particular bit of information, whether they're on step 4 or step 8, is going to be stored within the process engine itself. And so your application doesn't need to worry about what step comes next. That's handled by the workflow engine. And then, of course, you're reviewing all of this stuff, and somebody comes in and they say, okay, well, before we pay for the permit, some of them need to have an additional layer of approval. Okay, cool. So in BPMN, it's as simple as adding another gateway, right? And in BPMN, we support these human tasks. And so that's what that task is at the top. And zooming out a little bit, this is what the process now looks like. Ta-da. Oh, they come back in, of course. We have new requirements change for the application. We should probably send a reminder before we cancel the permit. Like maybe they just forgot to pay. We should probably be nice about that, right? So there's a lot of different ways to do that. Let me see if the little highlight thing works. Haha. So there's a lot of different ways to do that. But in BPMN, oh, it's not showing up on the screen, is it? It's right there. We can add a second boundary timer event, is what it's called in BPMN. But we just add another clock symbol to that. It's got the dashed line, which means it's non-interrupting. So we can put some sort of interval on that to say, every day we're going to send a payment notification. So every day the process engine just automatically moves to that top step to send a payment reminder notification. That step ends, goes back to collect payment, and it's waiting. You don't need to write any additional code. We already have an email service. So we can tie that right back into our existing email service. You don't need to deploy any infrastructure changes. You just need to deploy a new version of the diagram. The workflow engine, is going to automatically handle that, and there you go. So this was really, really brief, right? I don't expect anybody to be a BPMN expert coming out of this. I don't even expect you to really understand how the BPMN integrates with your application. Other than just kind of trusting the weird guy with the balloon on his head to tell you that it does and it will, and it's very, very easy to do. But this is kind of what I want you to take away from the talk, right? I want everybody to just kind of be aware of a different way to solve these problems within their application. You don't necessarily have to use Kafka and all these topics and message queues and subscriptions and you name it, right? There's a bunch of different solutions out there. You can literally open up something that looks like Visio, create a diagram, it's executable, and that's what's going to manage that step-by-step process within your application. We, of course, I'm going to recommend BPMN. I'm sort of paid to say that. There are other solutions out there. There's workflows as code, similar to what one of the other sponsors here has. Where you actually write the same thing, but instead of having that visual designer, it's in code. There's benefits to that. It's much easier to onboard a development team, because if you're a Java developer or a Golang developer, you're just writing in your native code. There's kind of no overhead to really understand other than what the API of that particular client looks like. But there's some downsides too, right? That's now integrated into your code base. It's not separated, and it's still code. You still don't get that kind of at-a-glance understanding of what's happening under the hood. Whereas with BPMN, you have that visual diagram that becomes living documentation for you and your team and the business to understand what's happening. So you have BPMN. You have the BPMN engines. There's various ones out there. There's open source, there's closed source. There's ones that kind of have their own kind of proprietary twist on top of the BPMN spec. There's lots of options that are out there. But once you have that diagram, there's some sort of engine out there that will execute it step by step, maintain that state for you. And I guess just to say it explicitly too, in the event of a crash, right, those engines maintain the state. So if you turn off the engine and turn it back on, process 24 will still be on step number 4, and process 306 will still be on step number 7, or whatever it needs to be. So you have simplified management. For some things, of course, this isn't going to apply to every single process you run within your company. But simplified management, right? It's very easy to add maybe a timer event, to add a notification to something, or to cancel a process. You just drop a timer event in and off you go. It's a lot easier than solving it in some other ways. And again, the living documentation, for me, this is the biggest benefit, being able to draw that out and not take a picture of a whiteboard, go back to sprint planning, 3 weeks later, come back for the demo and cross your fingers as the developer and say, yes, I promise, like exactly what we drew on the whiteboard is what we implemented. There is no translation layer between that. Exactly what was diagrammed within BPMN is exactly the steps that are followed by the workflow engine. So you're kind of taking a little bit of that mystery out. It becomes a living piece of documentation that you can share with the non-technical stakeholders. They can understand it quite easily, as you saw from those diagrams. You don't even need to really know BPMN to know what the process is. It's easier to onboard engineers. There you go. I didn't explicitly make a slide for it, but of course there are some situations where this doesn't work. If you have a quarterly cleanup job, probably still just run that as like a scheduled task on the server. This is really meant for kind of those cross-boundary, longer running, high volume processes that might come through. For those little one-off tasks, there's definitely better solutions than drawing a BPMN diagram and deploying it to a workflow engine and creating all of these hooks. So that was my 30 minutes. Thank you for coming. I'm sure there are some questions. One question. Yeah.
If part of the workflow includes steps that are performed by a vendor, how do we have that incorporated back into BPMN engine?
So it's, if we go back to one of the diagrams. So for instance, let's say the email tasks. Let's say you don't have an email service. Let's say you just want to integrate with SendGrid directly, right? You can just call SendGrid right from there. Again, like speaking from the Camunda perspective, we would recommend using that connector, so that little reusable bit of code that would just call out to SendGrid. And then it's expecting a response from SendGrid based on whatever their API is currently.
And for direct calls to vendors, that makes sense, but what happens if there's a workflow within the vendors?
Like you have to wait on it?
It's waiting, or it's kind of almost like a black box to us, but
Yeah.
you need to go through steps. And that's
Yeah.
like what you would diagram from a process perspective, but in terms of actually knowing what step in that it is, we have
Yeah.
flexibility.
So there's two ways you can solve that. So first, the way that you would model it for execution is you wouldn't model any of the steps within the vendor, right? You would just model the vendor call. That's the black box. That's what you're relying on as a company and as a developer. What you can do is just build out another model and link it if you want, just sort of like as a reference that says this is what's happening within that vendor if you wanted to go through those steps. In terms of the execution, right? Like say it's actually a credit report is a good example. Well, maybe not anymore. Back 15 years ago, I worked on an online banking application, and when we pulled a credit report, there was a delay, and it was a webhook response back to our application. It wasn't an immediate response. So one thing you can do is essentially it's sort of like signals. So there's a certain symbol you can pause on within the BPMN diagram, and you can wait for the application to send a response back to the workflow engine to say, okay, we've received this data, now you can move on. So kind of in between two of those tasks, you would have another diamond shape that's waiting on that response. It's called a message event within BPMN. And so your application would just send that message event back to the workflow engine when it receives that response. Again, within Camunda, we support a native webhook capability that binds directly to that symbol, so you don't even need to write any code for it. Just the callback URL for your request to that vendor, you would plug in the webhook endpoint. So there are ways to do that. BPMN extends way beyond what I've put on the screen here, but hopefully that kind of answered the question.
Yes, thank you.
Yeah, up front.
So I have this before, it's just been 5 years, so I can remember the acronym. The one thing I remember is that the state of the art, it's probably more than 5 years now, but for kind of allowing business users and developers to kind of edit the diagrams together was not the greatest. Is that improved? Are there better tools now for doing that sort of thing? 'Cause that was kind of our goal, but then never really.
Yeah. And sorry, I didn't repeat the other gentleman's question for the recording. The other question was, how do you handle like vendors where there's a black box? Do you model those steps? The question here is collaborative modeling, basically. What's that experience like to get multiple users in some sort of application to collaborate together on this model? It's not as good as Google Docs. Not even our modeler is that good. Everything is much better than it was a few years ago. And I think the biggest thing is just understanding how you want to source control that is my personal recommendation. Underneath the hood, underneath this model, it's XML, which isn't always the best to work with. But if you have a solid designer that's creating well-formatted XML, it's very easy to plug that into source control. Then you can kind of see the diffs between the two. We're able to show that within the modeler, and not just our modeler either. There's several other vendors that have a BPMN modeler that can show a diff between two different versions. So, if you get too many users inside of a modeler, you're going to run into some conflicts. But if you get a couple users in doing a collaborative session, most of the tools are pretty reliable these days. And then underneath it all, you have that source control to be able to view what those changes were. Yeah.
What would be the advantages and disadvantages compared to something like AWS step functions?
Yeah, so advantages or disadvantages to something like step functions. So step functions are one, your sort of vendor lock-in, right? Like if you want to migrate away from step functions into another platform, you've got a much higher workload than exporting a BPMN model and importing it into another engine. But two, it's kind of hard to compare the two because we're sort of solving two different things. Like with step functions or even like consumer applications like Zapier, you can link things together step by step in a very visual sort of way and provide some sort of execution that's going to happen for each of those tasks. But the difference is this provides, we like to say that we're the universal process orchestrator. So we can plug in with any system regardless of where it lives. And we've proven that time and time again. But on top of that, you don't have that same sort of like that pause for a human intervention, and also long-running tasks. And I think those are the two kind of key differentiators. If you have a process where you could fully automate it step by step, every single bit of it through something like step functions, now try to do that like manual application validation in the middle of that, right? So you tried to match a permit, it didn't match automatically in the system. Maybe it threw an error, maybe it didn't, however you handle that. And then you have some user who has to log into the application, they have to manually review that data, manually set a couple values on it, submit it back, and then that workflow has to continue the way that that it's supposed to move on to step 2, step 3, step 4. That's a lot harder to achieve within a system like step functions than it is with a BPMN engine. And same with long-running processes. Like we have some customers where their processes last for like a full year. And kind of just managing that within step functions can be quite difficult. Yeah. Did that? Okay. Another question.
One thing that step functions is very good at is like kind of massive parallelism
Yeah. Question was, step functions are great at massive parallelization. What does that look like in BPMN? So of course we do support like the parallel gateway, so within a process you can fork out into as many tasks as you want. Within the BPMN spec there's call activities and sub-processes as well, so you can kind of abstract those into smaller units, which makes it easier to visualize some of those. But in terms of execution, we have customers that are running 5 million rather way more complex processes than this every minute. So in terms of like the execution of the diagram, it's going to largely depend on the number of resources you put behind it. And how those resources scale is going to depend on your particular BPMN vendor. For Camunda specifically, we scale linearly. So if you have a set number of processes with a certain number of tasks, we can actually give you a formula that says, okay, you want to scale from 1 million to 10 million, we can tell you exactly how many resources you need to put behind it to achieve that. Yeah, we have a couple, I'm not going to say any names because I'm never quite sure of the NDAs and all of that, but we do have some fintech companies that are running like international payments and clearing payments through Camunda, and they're processing millions and millions of transactions every single day, and they're barely a bump on our radar. Or on the fun side, for the nerds, JPL uses Camunda. When the radio data comes down from the Mars rover, it runs through a Camunda workflow to like process the radio transmission and get the images and all of that, which is fun. There's a white paper out there about it. Yeah, up front again.
What does the kind of APM would look like for error exception handling for this process?
What do you mean?
Like if things are failing somewhere in the middle.
So just like, yeah, so what does like error and incident handling look like? So there's two different ways to think about that in the BPMN world. One is actually on this diagram, which nobody noticed. On the left side for the matching permit, there's now a lightning symbol. So whereas before, in the previous diagram, that service would have returned a bit of data that said matched true or false, and it went to that gateway and forked out. Now that service would throw an error. But it's a purposeful error. It's an error that we're expecting. It's a known kind of error condition. So we're going to catch that error event, and we're going to explicitly model what happens in the process when that error occurs. So that's kind of the best practice, right? Be as explicit as you can. You don't want any sort of implicit mystery happening behind the scenes. With this being your living documentation, what's being executed, you want to be as explicit about that as possible. But of course, there are the unknown unknowns, to quote the Jurassic Park talk from yesterday, the Donald Rumsfeld matrix, and that was a great talk, catch the recording later. And we call those incidents, right? So that would be maybe there's some sort of failure within the engine itself, right? Like a cloud outage or something like that. Or there's an error that occurs that you didn't account for in the modeling. For instance, maybe one of those gateways is looking for a variable named matched, and it wants it to be true or false, and you returned a variable named is a match or something, true or false. Well, now the engine doesn't have a variable to match, so it's going to stop, and it's going to throw an incident of some kind. Now again, how that incident gets handled is going to depend on the particular BPMN vendor. Within Camunda, we have a system called Operate, where you can log in and view all of those incidents. You can correct the variable data, move on. We also provide a full API behind that, so you don't necessarily have to log into the system. You could query the incidents and then resolve them through the API as well. But how you're going to handle that incident is going to vary based on the BPMN vendor.
Do you have real-time dashboard as well?
Real-time dashboards? Yes. One thing, because I didn't want to make this a Camunda sales pitch, and actually they asked me not to, but we offer things like heat maps, so you can come in and look at a diagram like this and see both how frequently a certain task was executed or how long that task took to execute. We've had some companies who spend a lot of time making this fancy model, and then 6 months in they look at the heat map and there's a whole branch of their model that's never been executed before. Well, it turns out you don't really need that part of your business anymore. We provide all the real-time stats with the running, how many times the jobs have been called, all those metrics. And again, all of the BPMN vendors have some sort of version of that. It just depends on like how you're querying it and how they present it to you. Yeah.
How do you handle editing, like a process if there's one that's ongoing? You said one could take a year, so if there's something that changes, is that are they versioned and it keeps the one that started in?
Yeah, so the question was, how do you handle editing workflow? Is there versioning? If you have a long-running process, what does that look like if you're making changes? Again, depends on the vendor, but pretty much every vendor out there supports some form of versioning, where they can support running multiple instances of that process or multiple versions of that process. So you would deploy a new version. When that start event happens, it would default to the newest version, but anything that's executing on the old version would still sit there. And unlike some other solutions like workflow as code, because it's this XML document basically that sits out there, and it's relatively light, right? It's only a couple kilobytes even for the most like complex models. That can just kind of sit there and it can still, the engine can still execute through the old version without taking up a whole lot of additional resources. And then once all of your processes are done, then you can remove that old version, ensure that everything goes to the new version. There are some platforms, Camunda supports it, but not all of them do, that support process migration. So being able to deploy a completely different diagram with completely different steps and then kind of map between the two and say, okay, this variable now should be named to this task should now be over here, and try to kind of move from an old version to a new version. So that exists as well. Yeah, any other questions?
How would you handle downtimes if you can't afford downtime in process migration?
How would you handle downtimes? So do you mean specifically like if the process engine goes down and the processes aren't running anymore?
No, I'm like, there are requests in flight and now you need to migrate to a new model. How would you do the deployment of a new model without downtime?
Yeah, so similar to the other question, with the versioning, you just deploy the new version. There's no downtime in the middle. Now, if you're going to do that process migration, sorry, to back up for a step, you would deploy the new version. So you have version 1 running, and we'll say there's 10 processes that are still in flight that haven't completed yet. And you would deploy version 2. All 10 of those processes are still moving through version number 1. And then new processes would start on version number 2. So there's no downtime for those 10 processes.
There are long-running processes running that you want to complete on the new version, is that at all?
Yeah, so that's the process migration. So the question was, if you have long-running processes and you want to move them to the new one, how do you do that? That is going to be vendor-specific again. Not all of the vendors support that, but it would be process migration, where you would say, the match permit task now maps to this other task in version number 2. And so every process that's sitting on that task, we're going to migrate it over here. We're going to rename this particular variable, whatever those changes are between them. But it is like a manual review for the most part, because we don't want to make any assumptions about what your system is doing under the hood, right? We'll make a couple good guesses, especially with AI, like we're working on ways to try to automate as much of that as we can, but we're never going to do an automatic migration without you coming in and explicitly clicking OK, because we don't want to accidentally map, the wrong task to the wrong thing, the wrong variable to the wrong variable name. You would have to go in and review that and say, yes, okay, this is the migration that I want, let's go. But it is possible to do. Yeah. Any other questions?
There are automated retries.
Automated retries, yes. Exponential backoff, automated retries. So the retries, I believe, are part of the BPMN spec itself, and then just kind of how the exponential backoff and how those retries are calculated depends on the engine. But typically within most BPMN engines, specifically within Camunda, within our visual designer, we call it modeler, when you click on one of those, you have a sidebar with all of the properties, and one of those is retries and backoff, and you can configure those. Also, a lot of them offer it through the API. I know Camunda does. So you'd be able to handle it through the API as well if you needed to make a change on the fly. So like for incident handling, right? If the retries hit 0, you clear the incident, you want it to retry another 3 times, you could programmatically do that.
User experience question. lines up here, right?
Yes.
Do you have to sit here with a mouse and do all that to make it look like this, or do you have a solution that kind of makes that?
Yes and no. So this is our desktop modeler software. We actually, one of our open source projects is called bpmn.io. You can go to bpmn.io. There are many other BPMN vendors use our library to power their modeler. And that's what this looks like. Oh, you can't even see it on the screen. You guys are looking at me like I'm crazy. This is our modeler. And so it's as easy as just kind of clicking buttons. It's not very hard to line up the stuff that you want. We offer some tools to kind of help you do that. It's a little easy, but also if you get a particularly complex workflow and then you need to come in and put something in the middle, yeah, you're gonna spend a little bit of time kind of dragging the arrows around and making it look pretty again, unfortunately. That is one of the downsides to kind of the visual aspect. For me personally, I think for projects where this would apply, I think that little bit of extra overhead is more than made up for in the time that you would have spent updating all of your documentation. You're gonna spend less time moving those pictures around than you would updating all of the readmes in your Confluence page or wikis or whatever you have. So I think that there's a trade-off there, but I think the return on that time is much better, generally speaking.
Can we see what because that's XML under the hood, right?
Yeah,
Pull up the XML.
I can. Where is the XML button? Right there. So there's individual activities that are defined, start events. Oh no. Plug it back in. There we go. And this is all part of the spec. Like you can go to the Object Management Group website, look at the BPMN spec. There it is, right? What you'll find is that each of the engines will add a little bit of additional metadata within some of those tags that give some, specific execution parameters for how that engine is going to interpret certain things. But for the most part, it's pure BPMN spec. Yeah, and it's an XML document, which is about as pretty as you can make an XML document. Yeah. Another question.
How silly can you get with the conditions when you hit the little diamond? You say something like, if it's Tuesday, send the traffic this way, or
Yeah.
I want 20% of the traffic to go this way.
No.
No.
So you can and you can't within the diagram itself. When you get to one of those conditions, on each of the paths, you're gonna define whatever the condition is. Again, how you do that, depending on the vendor, is gonna vary a little bit, but it'll be, variable equals some sort of value, some sort of expression that'll evaluate the true or false. And that's how it determines which path it's going to take. If you wanted, if it's Tuesday, you could grab the date now, day equals Tuesday, go that path. Yes, you can do that. But something like 20% of the traffic, what you would need to have is a step before it that kind of queries for like a feature flag, or a step at the beginning of the process that queries for your current feature flags. Probably at the beginning of the process would be the best bet, because then that data is stored within the process itself and won't change. So if you have a process that's running, again, like the year-long process, those feature flags within the process wouldn't change over time. Whatever flags you started with would stay the same. So maybe your first task would be, I'm gonna fetch these flags, and then down the line you can decide what you're gonna do with it, right? If it's, yes, yep, as long as it evaluates true or false. The way we do that within Camunda is with an expression language called feel, which is part of the BPMN spec, as well, technically it's part of the DMN spec, but it's like a sister spec. So not something that's Camunda specific, but again, each of the vendors is gonna have a little bit of a different way on how you implement that expression, but again, as long as it comes to true or false, so that it knows to go, this path or that path, then it'll work. Yeah.
Do you recommend this
That's what DMN is. So the question was, would you recommend implementing decision rules with this? I didn't want to touch on that. That's what DMN is. It stands for decision model and notation. Basically, it's a bunch of tables that take a series of inputs and then match, like Google Sheets style, match a condition and then give you some sort of output. And then you can chain those together into what's called a decision requirements diagram. So you can kind of get a little bit complex with it if you want. It's a pretty powerful and flexible rules engine, but it's not very dynamic. It's for those very specific sets of rules. Really cheap example off the top of my head for that loan application, right? And they have a credit score of less than 500, you're just gonna no, right? Like that's a very easy thing, very static that you can put within some sort of rules engine. If you need something that's more dynamic, probably not using DMN, and you'd probably just want to call out to a service that you have a little bit more control over and can kind of control that dynamic input and output a little bit better. But yeah.
DMN is something that you can use within this?
Yep. Yep. So there are lots of BPMN symbols that I didn't even cover, but this business rule task is one of them where you would link that decision engine to it, basically. Yep.
In the case that your microservices are event-based, how will you track the process ID? Do you have to have like a trace ID or something, or to actually track the progress through the diagram?
Yeah, so how would you track the process through the diagram across services?
Yeah, like event-based, they're like,
Yeah. So the first thing I would say is, why do you need to do that? Like I would consider, do those services really actually need to know what that process ID is? Because you really want the state of that process to be managed by the engine itself. And that service should really only care about that one little atomic unit of work that it has to do. It has to match the permit and then return the amount that needs to be paid and whether it matched or not. And like that's all that service needs to do. It doesn't care about step number 2, it doesn't care about the process ID. Maybe it doesn't even care about the customer, right? It just cares about a couple of the values for the truck and that's all it needs. If you do need that process ID, when we talk about like those connection points, the little bit of boilerplate code that you write in order to connect to the engine, that will provide you the process ID. So at each of those steps you would receive that. Or of course you can receive it at the beginning when the start event happens, cache it wherever you need to and move on with it. But I think the first question would be, do you really need it? Yeah. We've gone quite over, so everybody should go to lunch. If you have more questions, I'm in the balloon hat. I'm easy to find. Thanks.